switched on later. Hello. 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 എനിക്ക് ഇപ്പോൾ ക്ലാസ്സാണ്. കുഴപ്പമില്ലായിരുന്നു. എന്താ വിളിക്കാൻ എന്താ? ശരി, എനിക്ക് ക്ലാസ്സാണ്. NPTEL ക്ലാസ്സാണ്. എനിക്ക് NPTELൻ്റെ ക്ലാസ്സാണ് ഇപ്പം. NPTELൻ്റെ ക്ലാസ്സാണ്. NPTELൻ്റെ ക്ലാസ്സാണ്. ബൈ. Hello all, good evening. Welcome back to the
Good evening,
NPTEL.
ma'am.
Good evening. Welcome back to the interaction session of week 8 lectures. So let us wait another couple of minutes. After that we can start.
Ma'am,
Yes. Yes, Rilvana. Tell me.
uh, ma'am, why there is no class for at last Tuesday?
Last Tuesday we had class. Actually, the class was there. I don't know, like, what happened to you? Why didn't you join the class?
I joined, ma'am, but there is some issues, ma'am, in connection.
Okay, maybe actually the class was happening. Like, class has happened last week.
Okay, ma'am.
Maybe the problem is that all those who are joining after 7:10 and all, I'm not able to include them. Like, as the screen is shared, then I won't get any notification for that. Maybe because of that. I'll take care of that
Okay,
from
ma'am.
today.
Okay, ma'am. Okay, ma'am. Thank you.
Thank you. If you want to see last week's class, it is uploaded in the NBTL page. So you can go and
Yes,
check.
ma'am. Yes, ma'am. I know, ma'am. I know.
Yeah, yeah.
Thank you, ma'am.
Yeah, thank you. So I hope all of you have gone through the week 8 lectures. If not, kindly go through the lectures as soon as possible and kindly attempt all the assignment or quiz questions. I think the quiz is due for today or tomorrow. So kindly watch the NBTL lecture videos and attempt the quiz. Let us wait another few more minutes so that others can also join. So let us start today's session. I shall share my screen now. I hope my screen is visible. If not, kindly let me know. I guess students are still joining, so let me include them also. No, about the jam file comment in the comment box, actually that is a mistake. So kindly don't open that file because I was just trying to explore if that can be used for teaching. If it can be used, then it is more easy so that I can include people also in between the class. So as I am not that technically uh, highly qualified for that, I am not sure about how to use that. So maybe I'll just continue with the method which I followed till last week. So you need not worry about the jam file comment which is there in the comment box. So let us start the session. So, good evening, all. Welcome back to the interaction session for the course Wastewater Treatment and Recycling, Week 8 lectures. So, I hope all of you had gone through the lecture videos of NBTL lecture videos, and if not, kindly go through that as soon as possible because I guess your assignments are due for today or tomorrow. So, please go through the assignment questions also and kindly attempt that. So today in this video, in this class, we will be solving some of the questions which are taken from previous year assignment questions. We will be solving them. So let us start the session. So on week 8, the discussion was on the wastewater sludge. As we all know, the conventional treatment plants, conventional treatment units create sludge because in the primary and secondary treatment units, due to the process of settling, sludge is generated, and a majority, and you would have learned in the lecture video that majority of the cost in the wastewater treatment plant is occurring due to the treatment or management of wastewater sludge. Therefore, management of wastewater sludge is one of the important parameter while we discuss about the wastewater treatment. Hence, you have learned about wastewater sludge characteristics and their management methods in the last or week 8 NBTL lectures. And different sludge characteristics, different types of sludge such as primary sludge and secondary sludge were learned in week 8 lectures. And after that, you would have learned about the sludge management options, which include methods like sludge digestion, sludge dewatering, sludge hygienization, etc. So all these concepts were discussed in NPTEL week 8 lectures, and today's discussion will be based on this week 8 lecture videos. So let us quickly move on to the questions. So first question is, arrange the steps for sludge handling in sequence. So there are 5 processes given: drying, thickening, hygienization, dewatering, stabilization. So options are given, so you have to arrange them and pick up the right answer. So I expect your answers. Any lead, anyone?
C, ma'am.
C, thickening, stabilization, dewatering, hygienization and drying. Okay. Any
Option A, ma'am.
option A, stabilization, thickening, dewatering, drying.
Madam, option B.
Option B. Okay. So we have all the options. So let us see the correct answer. So the correct answer is option C, thickening, stabilization, dewatering, hygienization and followed by drying. So one by one let us see the processes. Sludge thickening is the initial step which is involved in the sludge treatment. In the sludge thickening, the water content which is present in the sludge, which is said to be about more than 90% of the sludge volume, the water content is reduced in order to make sludge more in a more workable condition. So the first process is thickening, which is followed by stabilization. Stabilization is also known as sludge digestion. In the stabilization method or sludge digestion method, the sludge is made into inert form, where the organic content, pathogens, etc. are digested or removed with the same procedure we follow for anaerobic digestion of wastewater. After that, it comes the dewatering. After sludge stabilization, all the water content present in the sludge is removed with various dewatering techniques and followed by hygienization. In the hygienization method, all the pathogens present in the sludge is removed with various techniques which you have learned, and followed by drying in sludge. Commonly adopted method is drying in sludge drying beds. This is the sequence, and hence C is the correct answer. Any doubt, anyone?
No, ma'am.
Okay, so then let us move on to the next question. Next question is, which of the following can be viewed as a constraint of fuel based sludge use, such as incineration and gasification? A. Expensive. B. Ash generation and disposal. C. Requirement of skilled operators. D. All the above. So the question is, which of the following is a constraint for treatment or fuel-based sludge management systems like incineration and gasification? So you have options here. So any guess, anyone?
D.
D.
All of the above. Yes.
All of the above. Okay. Any other answer?
D, madam.
D. Okay. Then let us see the answer. The answer is option D, all the above. For fuel-based sludge management systems such as incineration and gasification, those methods are considered to be expensive. Then, based on the air pollution consideration and other parameters, we say that these processes produce a high quantity of ash, and disposal of such ash is another headache for environmental engineers. So that is also a constraint. And the other parameter is a requirement of skilled operators. Skilled labor is always needed for this fuel based sludge management systems like incineration and gasification. Hence answer is all the above. Any doubt, anyone?
No. It's okay. Fine.
Okay, then let us move on to the next question. So the third question is, which of the following is a major challenge in sludge management? A. Reducing water content. B. Managing risk-causing organisms and chemicals. C. Recovery of nutrients, mainly nitrogen and phosphorus. D. All the above.
Madam, all the above.
All the above. Okay. Any other answer, anyone?
All, all the above, ma'am.
All the above. Okay. So let us see the answer. The answer is option D. All the above. We have discussed that sludge management itself is a very high-end process which requires lot of effort and lot of cost. So it itself, this method sludge management itself costs more than 50% of the cost of operation of treatment plants. Hence, discussing the major challenges in sludge management system, in the NBTL lectures, the professor would have discussed that reducing the water content itself is a major challenge, because most of the fraction of sludge consists of water. So reducing water content is a major challenge. The sludge, as the sludge consists of sludge also comes from this secondary sludge, that is after the secondary stage of treatment, which is usually biological treatment. The sludge is or it is full of microbes. There could be possibility of occurrence of this risk causing or disease causing organisms present. Also, in the sludge which is coming from the primary sludge, various chemicals could be present, which is resulted from the coagulation flocculation techniques or other processes. So this managing sludge with high pathogen content as well as chemicals is another challenge. Then coming to nutrients, since the sludge is itself is it consists of dead and living microbial organisms, they would be high in nutrients such as mainly nitrogen and phosphorus. Therefore, the management is very high challenging process. Therefore, C is also correct. Hence, the answer is D, all the above. So, shall we move on to the next question?
Yes, ma'am.
Okay. Before that, I guess some of you are still trying to join, so let me include them. Okay, welcome back. Let's continue the session. So, our fourth question is anaerobic sludge digestion is the process where option A digestion takes place only in the mesophilic temperature range, B similar to activated sludge process, C organic matter is chiefly converted to biogas, D all the above statements are true.
D.
Answer is D. Last
D.
D. Okay.
C, ma'am. C.
C. Okay. Then any other answer, anyone?
C, madam.
C. Okay. So I got some answers as C and D. Those who have said C, can you tell me why your answer is C?
Answer A is wrong because it also takes place in the thermophilic range.
Yes, you are right. Very good.
And in the activated sludge process, we are using aeration, which is
Aeration.
not there for the anaerobic process.
Yes, you are correct. Very good. So the answer is option C. Organic matter is chiefly converted to biogas. So as you have already discussed, the anaerobic sludge digestion takes place in both mesophilic as well as in the thermophilic temperature range. So the microbes are capable of doing the anaerobic digestion in both these temperature ranges. So this is already discussed in one of the lecture notes. So option A is wrong. Then comes the option B. Option B says that it is similar to activated sludge process, which is wrong because in activated sludge process is an aerobic process where the presence of oxygen is there for the microbial activity. However, the anaerobic sludge digestion, it is an anaerobic process where oxygen is absent, and the microbes convert organic matter into mainly biogas in the absence of oxygen. So option B is incorrect and option C is correct. Therefore, option C is the answer. Any doubt, anyone?
No, ma'am.
Okay, madam.
Okay, so then let us move on to next question. So the next question is dry solid contents of secondary sludge is typically A. Higher than dry solid content of primary sludge, B. Lower than dry solid content of primary sludge, C. Approximately similar to dry solid content of primary sludge, D. None of the above. Any answer?
Madam, answer is A.
Okay, answer A. Any other answer?
Madam, B.
B. Okay. Any other
It's,
answer?
it is B,
It is B.
but I have a doubt.
Okay.
I'll clarify it after you.
Okay. So any other answer, anyone?
But answer is C. Approximately the trisolids is maybe is equal in both cases. I hope that.
Okay.
C.
So C. So then let us see the answer. The answer is option B. It is lower than dry solid contents of primary sludge. So I'll tell you why. We are talking about two type of sludge, primary and secondary. So primary sludge comes from the primary treatment of the wastewater. So in the primary treatment, mostly the inorganics are all the settleable inorganics are removed, and in the secondary treatment mostly the sludge consists of biomass or microbes, which is in the form of MLSs, mixed liquid suspended solids. And in terms of dry solids, therefore primary sludge will be higher than the secondary sludge, because the primary sludge, the composition consists of mainly inorganic settleable solids. So that is why the dry solid content of secondary sludge is lower than dry solid content of primary sludge. Is it clear?
Ma'am, my
Yes.
doubt was,
Yes.
suppose it depends on settlable solids.
Yes.
If my wastewater does not contain settlable solids, it
Okay.
depends on my source.
Yes.
So how can I offhand say my primary sludge is going to be more than the secondary sludge?
Yeah, actually, here that's a good question. Here we are talking, like while we are talking about the conventional treatment systems, we are mainly referring to the municipal sewage. And in the case of municipal sewage, mostly in the primary sludge, all the settleable inorganics will be settled. And the second thing is that in the secondary sludge, the water content would be more. Therefore, while we categorize them in terms of solid content per liter of sludge, the the tri-solid content would be more in the primary sludge because of the presence of more water content in the secondary sludge, as they are mainly composed of the biomass or mixed liquor suspended solid. Is it
Thank
clear?
you. Thank you. Thank you.
Yeah. So any other doubt, anyone? So if not, let us move on to next question. So the next question is that in a dissolved air flotation thickening method, minute air bubbles get attached to solids and cause solids to separate from water in upward direction. This happens because A. Solid particle with attached bubble have lower specific gravity than water. B. Solid particle with attached bubble have higher specific gravity than water. C. Solid particle with attached bubble have higher volume than water. D. Solid particle with attached bubble have lower volume than water.
A, ma'am.
Option A. Okay.
Yeah.
So, the question is, in dissolved air flotation thickening, air bubbles get attached to solids and cause solids to separate from water in an upward direction. So, any other answer, anyone? Let us see the answer. Option A is the correct answer. Very good. The technique is based on that when air bubble get attached to the solids, the the specific gravity of the solid will get reduced because of the presence of this air bubble, and as a result of that, they get pushed upwards as the specific gravity becomes less than 1. They will rise up. So that is the mechanism of operation of dissolved air flotation. Hence the answer is option A. Any doubt? So various thickening methods
No, madam.
various thickening methods are discussed in the NBTL lectures. So you can have a quick read on that, like after this class or maybe while doing the assignments. Just read about various thickening methods which are commonly practiced for thickening the sludge. So dissolved air flotation is one among them. So if no doubt is there, let us move on to next question. So next question is that which of the following is not an advantage of sludge centrifugation? A. Less space requirement. B. Less order potential. D. Primarily used for primary sludge. D. All the above.
C. C, ma'am.
C. Okay.
Madam.
Madam B.
B. Less order potential. Okay. Which of the following is not an advantage of sludge centrifugation? Can anyone tell me why sludge centrifugation is done?
Blood centrifugal
For dewatering
to separate the water efficiently with a compact equipment.
Yes, very good.
Within a limited time, easily we can separate completely the soil sludge from the water, and it can separate into a soil contaminant.
Okay, very good. So it's it's a dewatering technique, and it is asked that which among the following is not an advantage of that process. So let us see the answer. The answer is option C. Usually, this centrifugation process is not practiced for primary sludge because because of the nature of the primary sludge, the it can if you perform the centrifugation for primary sludge, it can damage the equipment. Because of that, it is not used for primary sludge. Hence, answer is option C. Any doubt, anyone? It is there in the lecture video, so you can have a you can read about it in the lecture notes. Any doubt?
No, ma'am.
Okay, then let us move on to the next question. Which of the following sludge thickening method has the highest energy consumption? So this is based on the sludge thickening methods. So various methods are
D.
discussed.
Centrifugal.
Centrifuge, okay.
Answer is D.
Yes, madam. D.
D.
D. Let us see the answer. Yes, D is the correct answer. Centrifuge thickener consumes highest energy compared to other methods. So D is the correct answer. So let us move on to next question. So next question is, sludge digestion results in A. Reduction of total mass of solids, B. Removal of pathogens, C. Reduction of biological and chemical reactivity of sludge, D. All the above.
D, madam.
D. Okay. Any other answer, anyone?
Madam, C.
C,
C.
ma'am.
C.
C. Okay. Any other answer?
D is the correct one.
Okay, let us see the answer. Answer is D, all the above, because in the process of sludge digestion, it is similar to the process of anaerobic digestion of wastewater. In this process, this organic matter, due to the action of microbes, they will get converted majorly to biogas. So there will be a reduction of total mass of solids. Like the mass of solids will get reduced as there will be reduction in the organic matter, like organic matter content. There will be a reduction in total mass of solids. Therefore, that is an answer. Then as the sludge would be primarily consisting of these microbes, when it get digested, they will become inert, and therefore there will be a removal of pathogens. Though there is like 100% removal of pathogens is not achieved, there will be some amount of removal. Therefore, option B is also an answer. Then coming to option C, the primary intention of sludge digestion is to make the sludge inactive or inert, and therefore the biological and chemical reactivity of the sludge or microbes is reduced. Therefore, option C is also a correct answer. Therefore, all the above is the answer. Any doubt?
No, madam.
Okay.
It's okay.
So let us move on to next question. So next question is, which of the following conditions are not suitable for anaerobic sludge digestion? A. Psychrophilic, B. Thermophilic, C. Mesophilic, D. All the above. I think we have already discussed about this previously.
A.
A. Okay. Any other answer, anyone? I guess not, because we already discussed that anaerobic digestion can takes place in both these temperature ranges, thermophilic and mesophilic. Therefore, A is the correct answer. So shall we move on to next question? Let us see the next question. Select the incorrect statement regarding sludge conditioning. So option A is, it is done to improve dewatering characteristics of the sludge. B. Ferric chloride, lime and alum are used for thermal conditioning. C. The thermal treatment produces more readily dewaterable sludge than the chemical conditioning. D. None of the above. We have to select the incorrect statement.
B, ma'am.
Option D.
B. B.
Okay. Any other answer, anyone?
Madam, it's D. Last D.
D. Okay. Any other answer?
C, madam.
Option C. Okay. So then let us see the answer. Option B is the correct answer. Option, it is said that only option B is incorrect and other statements are true. So the sludge conditioning, it is said that it is done to improve dewatering characteristics of sludge. Therefore, that statement is correct. Then option B is, it is said that ferric chloride, lime and alum are used for thermal conditioning. It is incorrect because ferric chloride, lime and alum are usually done in chemical conditioning, not thermal conditioning. Therefore, as the method name mentioned is incorrect, the statement B is incorrect. Talking about option C, thermal treatment produces more readily dewaterable sludge than the chemical conditioning. So that statement is also correct. Compared to chemical conditioning, thermal treatment produces more readily dewaterable sludge. This you would have learned in the lecture. So that statement is also correct. Hence, option B is the correct answer for this question. Any doubt, anyone? So it appears that there is no doubt. So let us see the next question. Next question is that dewatering of sludge is done to A. Reduce weight and volume of sludge, B. Increase the calorific value of incineration of sludge, C. Reduce the probability of leachate generation of sludge, D. All the above.
Madam, D. D.
D.
Answer D.
D, madam.
Answer D. Okay. Any other answer? Let us see the answer. Yes, option D is the correct answer. Dewatering is done to reduce weight and volume of sludge, because in the process of dewatering, the moisture content or water content present in the sludge is removed, which comprises of most of the volume of sludge. Therefore, it reduces weight and volume of sludge. Then option B is, it increases the calorific value of incineration of sludge. Yes, it is a common knowledge that when the water content is removed, it becomes more, it can be taken for incineration, and therefore the calorific value of the sludge will be increased when it is dewatered. Therefore, statement B is correct. Then we have the statement C, it reduces the probability of leachate generation. So the leachate generation means that leachate is the liquid substance or the liquid content which oozes out from the sludge, which contain all the pathogens and all other pollutants or nutrients which is present in the sludge. Therefore, when there is no water present as a result due to dewatering, there will be no leachate. Therefore, the dewatering will help in reduction of probability of leachate generation. Therefore, statement C is also correct. So, hence answer is option D, all the above. Is it clear? Is it clear?
Okay, madam.
Okay, so let us move on to next question. Yes, the next two questions are numerical questions. So I think the same type of question is given for your assignment. So I just want everyone to solve this problem and then we will discuss the answer. It is said that the thickened sludge received from the secondary treatment with a total volume of 80 meter cube per day and a total mass of 1500 kilogram per day is to be digested in a standard anaerobic digester. So volume of sludge is given and the mass is given. And it is given that the sludge has 70% organic content and 30% inorganic content, and 60% of the organic fraction is converted to liquid and gaseous end products after a 30-day period. And it is said that digested sludge has a solid content of 5% and it must be stored up to a 90-day period. The question is to find out total mass remaining after digestion in kilogram per day unit. So I want all of you to attempt this problem, then we will discuss the answers.
Okay.
The same type of question is given in your assignment. So please attempt this problem. Anyone trying this problem? Anyone is trying this problem?
I think so. Waiting for that.
It's not doing.
Okay.
Madam, the answer is 2030 kilogram per day. Is it correct? 2030.
Okay, let us wait for others also.
Same, ma'am. 2030.
Same. Okay, let us see the answer then. Yes, it is correct. So I'll explain how it is done. So it is given that the total mass of solids is given for the sludge. It is 3500 kilogram per day, and it is given that wait a minute. Yes, it is given that organic fraction or organic content in the sludge is only 70% and inorganic fraction is 30%. And and in the question itself it is said that about 60% of the organic fraction is converted to liquid and gaseous end products after 30-day period. Therefore, after the sludge digestion, only only 40 percentage of this 70 percentage fraction will be remaining in the digester. Remaining everything will be converted, that is 60 percentage will be converted to liquid and gas. Therefore 40 percentage of this 70 percentage organic fraction will remain in the system. Also this inorganic fraction of 30 percentage will remain. So now we know the total mass of solids 3500 kilogram per day. Based on that, the total next step is the calculation of total organic fraction of solids. Therefore it is given that 70 percentage is the organic fraction. Therefore 3500 into 70 percentage, that is 2450 kilogram per day is the total organic fraction of the sludge which is coming into the digester. And then in the question it is said that 60 percentage will be removed. Therefore the only 40 percentage of this 2450 will remain in the digester after digestion. Therefore that is equal to 0.4, which is 40 percentage, into this 2450, that is coming as 980 kilogram per day. And we know that this inorganic fraction which is present in the sludge, they will not get converted, they will just remain as such in the digester even after treatment. Therefore that is coming as this 30 percentage of this 3500, that is about 1050 kilogram per day. Therefore from these information, total mass of solids remaining after digestion is coming as this 980 plus this 1050 of inorganic fraction. 980 plus 1050 is coming as 2030 kilogram per day. So this much mass of solids will remain in the digester after the digestion period is complete. The remaining fraction, this 3500 minus 2030, that will get converted to gas and liquid. So is it clear?
Yes, ma'am.
Does anyone have any doubt? If there is any doubt, you can ask. So as there is no doubt, let us move on to next question. So the next question is a continuation of this same question, and it is asked to find out the digested sludge accumulation rate in meter cube per day. So can you attempt this problem?
Yes, ma'am.
I guess for this you need a density of sludge.
Exactly.
Yeah,
Required
so
answers.
density I will let you know. Okay. Take take density of sludge as 1010 kilogram per meter cube. So please attempt this problem. After that we will discuss the solution.
Madam, right, the answer is 2 meter cube per day.
The answer is
2 meter cube, 2 meter cube per
okay.
day.
Digested sludge accumulation rate is 2 meter cube per day. Okay. Any other answer?
40, ma'am.
40.
Yes, please.
Okay.
Mhm.
So let us wait another 2 minutes so that others can also solve. After that we will discuss. This type of problem is also there in your assignment. So kindly try to solve this, then after that we will discuss. Any other answer, anyone? Okay, let us see the answer. So the acceptable value is 40 meter cube per day, or in the range from 35 to 45 meter cube per day. So I'll explain why. So here in the question it is asked to find out the digested sludge accumulation rate. So from the previous question, total mass of solids after digestion we found out as 2030 kilogram per day, and it is given that the specific gravity of sludge as 1.01 or density as 1010 kilogram per meter cube. So we can find out the volume of sludge. It is asked to find out the digested sludge accumulation rate in terms of volume. So volume is found as mass of sludge which is accumulated divided by density. Also we have to incorporate you have got this value 2 meter cube per day because you have not incorporated this digested sludge solid content, which is given as 5%. See, all this mass need not necessarily contain the dry the solids. The solid content is given only as 5%. Remaining 95% could be from the water fraction which is present. Therefore, it is necessary to incorporate this 5% term which is given as the digested sludge solid content. Therefore, when you evaporate that also, the formula for calculation of digested sludge accumulation rate is coming as mass of sludge which is getting accumulated divided by density into solid content. That is coming as mass is from the previous question, it is calculated as 2030 divided by density is given which is 1010. The solid content is given which is 5%. You have not incorporated this 5% term, that is why you have got the answer as 2 meter cube. Therefore the answer is coming as volume is coming as 40.2 meter cube per day. Is it clear?
Yes, ma'am.
Okay. Any doubt, anyone? Any doubt?
No, ma'am.
Okay. So that was the last question for today's session. So thank you for your time. If there is any doubt, you can ask now. Next session will be on next Tuesday, 27th September, from 7 p.m. to 8 p.m. same time. So with that, let us wind up this session if there is no doubt. Is there any doubt? Thank you for attending today's session. If there is any doubt, you can ask.
Thank you, ma'am.
Hello, excuse me, madam. Just I have one doubt regarding that class sections.
Yes.
And can you explain that what are the main chemicals we used for sludge conditioning?
Yeah, for in the chemical conditioning method, we mainly use for this ferric treatment, ferric coagulants, then alum. So these two I know. Remaining things I don't remember. So I will let you know by quickly referring the notes. Just a minute.
Okay.
Ferric and alum is there in the chemical conditioning methods.
Madam, just recently I visited one chemical means effluent treatment plant, and
Okay.
the concerned of means people they use mainly alum for the sludge
Yeah.
chemical treatment. I saw that, and
Okay.
another is ferric and another kind of chemical I don't know about regarding that. So,
Ferric chloride, lime, and alum are usually used. So alum is commonly used.
uh,
Maybe because like in case of ferric chloride, the issue is that the ferric chloride has this light brown color tint is there. So that
okay,
affects with the, in case of water treatment, we usually say that if you go for ferric chloride, then that can impart color to the water which is treated.
okay.
So that is why in case of water treatment, we go for alum mostly.
Mm.
So in
But in the case of sludge treatment, which one is better? Alum.
in case of sludge treatment, we usually go for all these three chemicals: ferric chloride,
Okay.
alum, and lime. So
Okay.
based on the availability and by considering other factors like cost effectiveness and all, we usually choose the method or choose the chemical.
Okay.
Yeah.
Any other side effect or pros and cons? Any kind of
Pros and cons, as it is for sludge, I'm not sure about the pros and cons. Maybe I will read about it and I'll tell you in the next class.
okay. Thank you, madam.
Madam, I have doubt.
Yes.
Madam, why in sludge conditioning process polymer we can use most of the companies,
Yes, polymer can
but
be used.
anionic or cationic, whatever.
Okay.
But alum ferrichloride is not using in sludge treatment, na?
For actually for sludge treatment, for coagulation methods for sludge conditioning, we use alum and lime. Also, polymers can be used. The prime objective is to flocculate the sludge to get removed to increase the dewatering capacity.
Okay, madam. But alum and ferrichloride using
in primary treatment only, but sludge treatment we are using in polymer, cationic, anionic or neutral polymers.
Yeah.
In any effluent treatment plants, these type of polymers are using, not perchloride and alum.
Yes, I agree with you, but alum and lime can also be used. Polymer addition is one method of chemical treatment, but these are also used in terms of in sludge treatment. In primary treatment, we use alum and this alum and lime or ferric chloride. Same as in case of this water treatment, in sludge treatment also we can go for this alum or lime or ferric chloride. Our primary objective is to flocculate the sludge. And in water treatment, we can also go for this polymer addition. There are some studies in which they go for polymer addition in water treatment also. But it is not that common considering the cost effectiveness or other parameters and all. So in sludge treatment, we can go for ferric chloride or alum. Not an issue.
Okay, madam.
Yeah, it is also given in your lecture notes. You can see, I'll tell the slide name. It is in slide 43 or page number 22 of lecture notes.
Okay, madam.
Any other doubt, anyone? If not, shall we end the session?
Yes, madam.
Thank you. Let us meet on next Tuesday.